So last time we were talking about vertical motion. So the vertical motion is exactly same as horizontal motion, except in vertical motion, the acceleration is due to the gravity. Okay. So in the horizontal motion, to accelerate something, you need to either push or pull. Okay. For example, if I want to accelerate this object, I need to push it or I need to pull it. But in case of vertical motion, gravity is pulling the object. So you drop an object, it falls because of the gravity. So the acceleration comes from the gravity force. That's why it's called acceleration due to gravity. Okay? And it's always same for vertical motion. Is due to gravity. So whenever you do any kind of vertical motion problem, the acceleration would be 9.8 meters per second squared. It's constant. And the sign would be negative, because just like in the horizontal motion, we consider up to be positive and down to be negative, whereas in the horizontal we considered right to be positive and left to be negative. Okay? So because the acceleration is pointing down, okay, this acceleration points down, so it's negative. And what this means is, the meaning of this is every second when you drop something, an object, its object's velocity changes by 9.8 meters per second. Okay? That's the meaning of minus 9.8 meters per second squared. So if I want to show that in a picture, starting with the object at rest, its velocity is 0. In the next second, okay, 1 second later, its velocity will be 9.8 meters per. I will not write the negative. Okay, we'll just have negative sign for all the values. So I'll just not write the negative sign. And in the next second, it'll have 9.8 plus 9.8, so 19.6 meters per second. In the next second, it'll have 19.6 plus 9.8. Okay, so that would be 29.4. Okay, and then in the next second, it will have additional 9.8. So every second, the speed or the velocity increases by 9.8 meters per second. That's what this acceleration is. Okay. Besides that, everything else is same. Okay. So instead of delta x for vertical motion, we'll be using delta y. Okay. The position in the vertical motion is denoted by x initial, y initial, and y final. Okay. So let's look at a problem to see how we apply the formulas. Let's look at the first problem on worksheet 3. Okay, so let's see what things we are given. A €1 coin is dropped from the Leaning Tower of Pisa and falls freely from rest. What are its positions and velocities after 1 second, 2 seconds, and 3 seconds? So it says it falls from rest. Okay, that means initially its velocity is 0. Okay. So Vi is 0. And whenever we deal with any kind of vertical motion problem, you can consider A to be negative 9.8, whether it's moving up or moving down. For both cases, that's the acceleration. Okay. And then the time is given, so that's t, 1 second. And we want to find the position. Okay. So we want to find final position. And we can consider that the initial position is 0. Okay. So start at y is equal to 0. So that's the 0, and then it's falling down. So consider y initial is 0. And then we also want to find, sorry, that's not, I meant to write question mark here because that's what we want to find. Okay. So that's the question mark. We want to find final position, and we also want to find final velocity. Okay. So we have 3 formulas. Acceleration is v final minus v initial over time. Delta y, we had delta x before, but now we will be using delta y. So v final squared minus v initial squared over 2a, and then also delta y is equal to vi t plus 1/2 at squared. Okay. In the next chapter, we'll be using subscript x and y for velocities also, but for now, we don't need to do that. So which one we should use for the first one? So we have initial velocity given, time given, and acceleration known. Okay, that means we can use this one. So delta y is y final minus y initial. Okay, so y final minus y initial is vit plus 1/2 at squared. Y final is equal to, so this thing is 0 because it starts from the 0 position. Okay, so that's 0. So the initially is also 0, starts from rest. Okay, that's what we have here. Time is 1 second plus 1/2. A is negative 9.8 meters per second squared, and t is 1 second. Okay, so we have negative 9.8 meters per second squared over 2, and you have second here, so this would be second squared. So second squared and second squared would cancel. So that's 9.8 over 2, which is 4.9. Okay, 4.9 meters. So its position after 1 second would be 4.9 meters down. So this negative sign means in the down direction, okay, or below the origin. If it is positive, that means it's above the origin. So that's the final position. Now we want to find final velocity. So we have 3 formulas again. Which one should we use? Second one. Yeah, second one, we can use second one. We can also use the first one, this one. So A is V final minus V initial over T. Okay. So rearrange the terms. You can write this as V final is equal to V initial plus AT. Okay, just rearranging the terms from left to right. So V initial 0. Acceleration for downward motion or upward motion is always 9.8 meters per second squared. Time is for 1 second. So that gives us negative 9.8 meters per second. Okay, second and this second cancel with one of the seconds here. So this negative sign implies that it's falling, okay, moving down. Okay, so that's number one. Let's look at, so you are also asked to find the same thing for other times, okay, 2 seconds, 3 seconds. I will let you guys do the other times. So you want to do same thing for other times. Okay, let's look at number 2. So please read the question. You throw a ball downward from a window at speed of 2 meters per second. How fast will it be moving when it hits the sidewalk 2.5 meters below? So let's say you've dropped something from the window, and this distance is delta y, displacement from initial point to final point is 2.5 meters. Now displacement is a vector quantity, so if it is below, if it is moving down, this would be negative. Okay, although the question doesn't tells you, the question doesn't say whether it's positive or negative. I think it's, yeah, it says it doesn't give a negative sign, but you still need to put minus sign here. Okay, 2.5 meter, because it's falling down. If it is going up, then it will be positive. So we have delta y is negative 2.5 meters, and then the starting speed, initial speed, is 2 meters per second, and then we need to find the final velocity, how fast it would be moving just before hitting the ground. Okay, here, what is the final velocity? And one more thing we know here, that is acceleration. Acceleration is always 9.8 meters per second squared. So we have 3 formulas. You need to decide which one you want to use. Okay, so for this one, you can use Vf squared is equal to Vi squared plus 2a delta y. Okay. In the horizontal motion, we had delta x here, but now we have delta y. Everything else is same. So Vi 2 meters per second squared plus 2a negative 9.8 meters per second squared delta y negative 2.5. Okay. So if you do the math, this will give you Vf squared is equal to 45. So this would be 45. We have meters second squared. Okay, so that means we have meters squared second squared. So if you have a square on the variable, how do you get the value, the variable? Get rid of the square. You put square root on both sides, right? So when you remove square root, square, you need to include square root here. Okay? Also plus minus. Because when you square this, this will be 9. Okay? So when you get rid of square, you need to put plus minus square root. So you do the same thing here. Okay, Vf is plus minus square root of 45. Okay. So you need to find the value of square root of 45. If you use your calculator, it will give you 6.7. Okay, the unit of velocity is meters per second. Now plus minus has the physical implication here. This means going up, this means going down. In our case, it's going down, so our answer should be in negative. Okay, the positive is irrelevant. So negative 6.7 meters per second, because the object is moving down. Okay. So let's look at number 3. This is a similar kind of question. So from a top of a 70-meter building, I don't know what happened. So you you throw a ball straight up from 70-meter tall building. So you have a building, this is 70-meter tall. Okay. So consider that this is our origin. Okay. So that's 0 mark, and from the origin to the top of the building is 70 meters. So y is 70 meters, and our ball is somewhere here. Okay. We don't count the height of the person. Compared to the building, the height of the person is negligible. So we just consider that the ball and the person are at the same point. Okay. So that's the ball, and its initial position is 70 meters from our origin. So yi is 70 meters. And you throw a ball straight up at 6 meters per second. So initial velocity is 6 meters per second. That's the information given. The ball misses the building on the way down. Okay, it goes up and then misses the building and it falls down. What is the maximum height of the ball? So how high will it go? So we want to find this height. Okay, y final. Initially it's at 70 meters high, and where would it end up at the highest point? So we know the acceleration is always negative 9.8 meters per second squared. Okay, so we want to find yf. And we also know one more thing here. It's not given, but you can, just by using common sense, you can tell that at the highest point here, the final velocity will be 0. Okay, it will momentarily stop at the highest point. If I throw something up, it will stop momentarily and it falls down, because we are dealing with the highest point. So at highest point, final velocity would be 0. Okay, that's something we need to know, even if the question doesn't tell you. So now let's use a formula that is relevant here. Out of those three, you need to decide which one is relevant. Okay. So the one that has initial and final velocity is this formula. So final velocity squared is equal to initial velocity squared plus 2a delta y. Okay. Delta y displacement is final minus initial. Okay. So instead of writing delta y, sometimes you can just write sometimes just use right y final minus y initial. Okay. So we want to find final velocity. Initial velocity is 6 meters per second, that squared plus 2 times negative 9.8 meters per second squared. Final position, this is known. I think I didn't say it right. So this is known, this is 0. Final velocity is 0. What we are finding is this final position, okay? Want to find yf. Initial position is 0. Sorry, not 0, 70. Okay. So 0 is for the final velocity because it's at the highest point. So we want to solve this equation to find this thing, yf. So let's do that. So tell me, how would you find yf? What step would you take to solve this? So you can take this to the other side. So 6 squared is 36. Take to the other side, it becomes negative 36. So negative 36. So when you are doing the intermediate steps, you don't need to write the units. Okay. Sometimes units are a little bit messy. You can you don't need to write the units. You can just write the unit in the end of your answer. So 36 to the other side. So this is negative 19.6 yf minus 70. Okay. And then you can divide both sides by 19.6, negative 9.6, negative 19.6. Okay. So this thing will cancel. Negative and negative cancel. So 36 over 19.6 is equal to yf minus 70, and then yf is this thing, that would be 1.8 plus 70, that is 71.8 meters. Okay. So the ball will reach 71.8 meters from the ground. Okay, we are measuring with respect to ground. If you measure from here, then it will be just 1.8 meters. Okay, just if you measure, come on, just measure from here, it will be 1.8 meters. But from the ground, it will be 70 plus 1.8. Okay, so let's look at part B. Okay, so those who are on Zoom, you can download this from Blackboard. It's already uploaded on Blackboard. So So what's the velocity of ball after 2-second time? So again, we have A, negative 9.8 meters per second squared. Okay, we don't know the final velocity, so we don't know what the velocity would be after 2 seconds. That's what we need to find. But we know the initial velocity, Vi is given, 6 meters per second. And we also know the times. We want to find after 2-second time. And again, to solve any kind of problem, we only need 3 quantities. Okay? Once we have 3 quantities, then you can find the rest. So decide which one you want to use. So we have this formula, So it's doing some funny thing now. Let me just close it and so we have this formula V final is equal to V initial plus AT. So V initial, can plug in the V initial 6 meters per second. Okay. Let me make it a little bit darker. Acceleration is negative 9.8 meters per second squared, and the time is 2 seconds. Okay, so do the math, and that will give you the final velocity. So I will let you guys do this one. Okay, so why don't you calculate this and tell me the answer. Does anyone have answer for this? No, negative 13.6. Okay, that's good. So negative sign again means it's falling. In 2 second time, the ball would be falling. Okay, so the next part, what's the final velocity of the ball just before hitting the ground? So you have ground here. So just before hitting the ground, what's VF? We know A is negative 9.8 meters per second squared. What would be the final position of the ball just before hitting the ground? What's the final position? 0, exactly. So that's 0. Because this is 0 mark, it went up and then ended again back to 0. So final position is 0. Initial position is also 0 because it started from 0 mark. And we also know initial velocity, 6 meters per second. So that means we have delta y, y final minus y initial is 0. So we have 3 quantities. Okay, so we have A, we have delta y, vi. So if we have 3 quantities given, then we can find the rest. So which formula should we use? So you need to decide from those 3 formulas which one would be the relevant one. So you can use V final squared is equal to V initial squared plus 2A delta y. You cannot use the one with the time because time is not given. Okay, we need to use the one without time. So V initial 6 meters per second squared plus 2 negative 9.8 meters per second squared. Delta y is 0. So Vf would be square. So this term would be 0 because 0 times anything is 0. So that will be plus minus square root of 6 squared. Okay. So Vf would be plus minus 6 meters per second. Now in this case we'll be choosing negative sign because it's for the falling object. So 6 meters per second is the final velocity. So what you can say about the velocity at the same level is whatever velocity it starts with the same velocity it ends to that same point. Okay. So at the same level it will have same velocity. Just a second, let me make sure this is right. Just a second, my mistake. So this velocity, no, we cannot use this one. Okay, so this is very important. So this velocity is when you throw the ball from this height. Okay, so from here. I didn't realize that the ball was thrown from here. So at this point, initial velocity is 6. It's not from here. So that means we need to consider this point as our initial point, because we don't know the initial velocity at this point. Okay, Vi is not known. Does that make sense? No? So the reason we cannot use this initial velocity is we are considering this to be the origin. Okay, for this origin, that's not the velocity. Okay, because you throw the ball from here. So you need to consider this to be the origin. Okay, I mean if you knew this velocity, then you can consider this to be origin. That's fine. Okay, but since we didn't know that, so we'll modify this a little bit. Okay, so let's just do not cross out. So we'll just do a little bit of modification here. So consider that this is our origin. We shift our origin here. So this is 0 mark. Okay, let me use different color. That's the 0 mark. You can choose any point as your origin. Okay, origin is not fixed. It's perfectly arbitrary. Why is it doing that? Okay, so this is our origin. Okay. So initial origin is that's fine. Now once we choose that origin, now we can say our initial velocity is that. So that is now also fine. Okay, we are good with that. We are good with that. Now tell me what's the final position. If we choose this to be our origin, this is where the ball lands. So what's the final position? In other words, yeah, exactly. How far the object will be from here. From 0 mark, it would be that much far. So that means it's negative 70 meters. So this would be negative 70 meters. Okay. So our delta y would be final minus initial. So that would be negative 70 meters. Okay. Acceleration is fine. It's always same. No problem. So everything else is same. So let's just use the right numbers here. So that's fine. A is fine. So delta y is negative 70. Okay, not 0. Okay. So with that, so let's see what we get. I want you guys to do the math. So this is 36 plus minus 19.6 times minus, and minus would be positive here, so 70. So see what you get if you do the math. That's v squared. Do you guys have an answer? No answer? So when you'll get a number here, okay, and if you take the square root of that number, you get plus minus 37.5. Okay, that's what I have. Yeah, so someone watching also got the same answer. Okay, so that's that. Now, because it's falling, that means we choose negative sign. Okay, so this would be negative 37.5. Okay. So making mistakes in physics is perfectly fine because it's a part of learning. If you don't make mistakes in physics, you don't learn. So when you make mistakes, you see where you made the mistakes and you will realize what you actually are supposed to do. Okay, so then let's look at part D. Okay, now the ball is thrown straight down at 6 meters per second. What is the velocity of the ball after 2 seconds? So how do you do that? So ball is thrown down at that speed, means initial velocity is now 6 meters per second. Okay, -6 actually. So you throw the ball vertically down. And time is 2 seconds. What else you know? Yeah, exactly. So negative 9.8 meters per second squared. So we want to find VF. So VF is VI plus AT. VI is -6 meters per second plus negative 9.8 meters per second squared. Time is 2 seconds, and that will give us negative 25.6 meter per second. Okay, I'm not considering the significant figures here. Okay. It should be, it has only one sig fix, so if you want to write the right significant figure, then it will be 30. Okay. So what's the final velocity of the ball? So you need to use one of the formulas. So final velocity, we have two formulas for final velocity. Out of two, let's see which one would be relevant here. We can just use this one. It's 2a delta y, y final minus y initial. So initial velocity is -6 plus 2 negative 9.8. Final velocity, final position is 0. Initial is 70. Okay. So if we do the math, what we get? So we'll have negative 37.5 meters per second. Okay. So that's about the vertical motion. In the next chapter, we'll be combining vertical motion and horizontal motion, and then you will be using both the cases, okay, in the problem solving. So we'll be using all these concepts later in the next concept. But now let's talk about vectors. Okay, so in the lab also we'll be talking about the vectors, but here I just want to introduce vectors very briefly. So vector quantities are the quantities with both magnitude and direction. We already talked about that. Okay. So when we are given a vector, let's say force, I don't know why it's doing that. So you're given a force, let's say you are applying force of come on. So you're given a force of 10 Newton, and let's say you are applying force of 10 Newton at 30 degrees to this x-axis. Okay, so you can write this force, the vector, in two ways. Okay, the first way is you can say I applied 10 Newton at 30 degrees. Usually this angle is measured with respect to x-axis. Okay, whenever you say 30 degrees, it's with respect to x-axis. Okay, that's one way. Another way, very important way, is in terms of unit vectors. Okay, so the meaning of this vector at angle of 30 degrees means a part of this vector is along x-axis and part along y-axis. So this is the combination of part along x-axis and part along y-axis. So we can separate the part along x-axis and part along y-axis and then write it as the components. Okay, so how we do that? So you draw a triangle from the end of the vector. Okay, so this is a right triangle, and then it'll have x component. So let's denote this by f. Its x component is down here, so this part is the x part. It's denoted by fx, f sub x, and it will also have y component. Okay, so this part is y component. So this vector is again combination of x component and y component. So we need to resolve or break this vector into these two components. So the way to do that is, if you look at this triangle, this side in terms of this vector, okay, this is f, this vector is f. In terms of this vector, this would be f cosine theta. Okay. This one, in terms of this vector, would be f sine theta. Okay. So our f sub x, x component is f cosine theta, and f sub y is f sine theta. We are just using the right angle triangle, okay, or trigonometry. So let me show you once again how we do that. So this is our triangle. Okay, if this is our f, if this is our theta, then the ratio of this, let's call this one fx and this one fy. So the ratio of fx over f, okay, adjacent over hypotenuse is what? Cosine, right? Cosine theta. That's the trigonometry. So rearranging that, we get fx is equal to f cosine theta. Okay. Likewise, let's take the ratio of opposite to the adjacent or opposite to the hypotenuse. Okay. Opposite is fy. Okay. That's the opposite. And then to hypotenuse, that's hypotenuse f. Do you guys remember what that is? Sine, right? Sine theta. You must have learned this in trigonometry. So rearranging that, we get fy is equal to f sine theta. Okay, so that's what I have here. Okay, now plug in the values here. So f, we are applying 10 Newton force, and cosine at what angle? We are applying at 30 degrees. Likewise here, 10 Newton, force is 10 Newton, and then sine 30 degrees. Okay, so what is this value? You get some value here, 10 times cosine 30 degrees. Tell me the value.
I got
1.54 Newton. Okay, so this one. Is that 5? 5 Newton. Okay. So we got both x and y component. So the vector f now can be written as the x component 1.54 Newton. This is along x direction. Okay. So in order to denote that this is along x direction, we write this thing called I hat. Okay. This tells us this thing is along x direction or x axis. And plus, we have this component 5 Newton, and this is along y axis. So to denote that, we use this something called j hat. Okay, this j hat tells us the other thing is along y axis. Okay, so this is another way of representing this thing, 50 Newton at 30 degrees. Sorry, 10 Newton at 10 Newton applied at 30 degrees. Okay, so we will talk more about this in the next class as well as in lab. We'll be doing an experiment on this in lab today.